Hello everyone, welcome back to another video. My name is Dylan, and in this one we are going through the arithmetic paper from the 2025 Year 6 SATs. We can see it here. Look at that front page, 2025, it's here, it's been released. We're going to go through every single question now, so skimming through some instructions and blank pages. Here is question 1. This is a place value question. 7,549 is the same as or equivalent to 7,049. Well, we have the thousands here, and we have the 40, which is the tens and the ones. We're only missing the hundreds, which is 500s. The trick would be just to put 5, but no, you need to understand that this 5 here is actually worth 500, of course. Question 2, 456 take away 385. Just whack it into column method. Why not? Make sure you get this answer right, because this is going to have an exchange hidden in there. In the ones, 6 take away 5 is 1. 5 take away 8, we need to do some exchanging here. 15 take away 8 is 7, and then the 3 take away the 3 cancels out, and we're left with 71. Make sure copying answers carefully into that box. I love this question. It's a different way of asking by multiplying by 0. How do I get the answer 0? By multiplying something by 233. Well, it doesn't matter what we multiply by. If we want the answer to be 0, we multiply by 0. 233 lots of nothing is still nothing. So the answer there is 0. Question 4, 47.65 plus 51.783. This is a classic addition question with decimals, where the number of decimal places is different. In the first number, we have 2 decimal places, 6, 5. In the next one, yes, the tens and the ones match up, but then we have 7 in the tenths, 8 in the hundredths, and then we have some thousandths at the end there. So as long as we match these up nicely and put them in the right place value column, we should get the right answer. Nothing plus 3 is 3. 5 plus 8 is 13. So whack the 1 down. 6 plus 7 is 13, plus the 1 is 14. Don't forget your decimal comes down. 7 plus 1 plus 1 is 9, and 5 plus 4 is 9. So copying this answer in super carefully, we get 99.433. Question 5. 904, getting ahead of myself, subtract 8. Now you could put this into a formal written method, or the way I would do this, I'd change take away 8 to take away 4, and then take away another 4. Taking away 2 lots of 4 is the same as taking away 8, and the reason I'm taking away 4 to begin with is because I have 4 left over in the ones here. So 904 take away 4 would be 900, and then I have 4 left to subtract, and then that would give me 896. I could just count backwards, or know my bonds to 100 to know there must be 96 left over there. Lots of ways to get to the answers in different questions here. 84 divided by 12. This is a times table question. How many lots of 12 go into 84? If you know your times tables, you'll be saying 7 straight away. Something you need to learn. 6 multiplied by 832. It doesn't matter that the smaller number has come first. We can put this into short multiplication. 832 multiplied by 6. We're going to start in the ones column. 6 times 2 is 12. 6 times 3 is 18. Plus that 1 gives me 19. And then 6 times 8 is 48, plus that 1 again is going to give me 49, and the answer is 4,992. Nothing too tricky so far. Good base knowledge of times tables, absolutely required. Question 8, 12 multiplied by 3 multiplied by 10. Well, I'm definitely leaving multiply by 10 until the end because it's the easiest number to multiply by. So let's do 12 times 3. Again, that's times table knowledge. We get 36. And then to multiply by 10, I make this number 10 times bigger. I put a placeholder at the end, and I get the answer 360. Question 9. 326 plus what is 380? Well, again, a trick here would be to see the plus symbol and think, oh, I've got to add these two numbers together. But that would be nonsense. We'd get a number in here, 700 and something, and it just wouldn't make any sense. No. We need a smaller number in here to bridge the gap from 326 all the way up to 380. Now you could count on like this. You could jump forward to 330. That's a jump of 4. And then you could jump forward in tens, which is 50. And you get the answer 54. If you're less confident with this method, just put it into a formal written method where we have 380 take away 326. You'll be lining your digits up much better than I am here. 0 take away 6, we'll do some exchanging. 10 take away 6 is 4, 7 take away 2 is 5, 3 take away 3 cancels. We still got 54. It just goes to show, what method are you more confident with? As long as you get the right answer, it's okay. It doesn't matter too much. Question 10, another multiplication question, but hidden inside of what looks like inverse with division. Basically, if you know your times table facts, this is something you can answer really quickly. What do we divide 72 by to make 9? I could write this out like this. 9 times blank equals 72. This is the same blank number. It's just the inverse. So knowing my times tables, I know that 9 times 8 is 72. So 72 divided by 8 will give me 9. All of these facts are linked together. Here we have our first quite tricky fraction question if we're not sure on the rule. Once we're sure on the rule, it's very, very simple. When we're multiplying two fractions together, we take the numerators, 2 and 5. 2 times 5 is 10. And then we take the denominator, 5 and 6, multiply those together, and we get 30. The answer is 10 out of 30. You could simplify it if you wanted to, but this would be enough to get a mark. Question 12, 540 divided by 6. Again, this looks like something where we might use short division, and we could, but what this is really getting you to notice is links between times table facts. If this said 54 divided by 6, and you were really strong with your times tables, you'd say, yeah, that's 9. But it's 540, it's 10 times bigger, so the answer is 10 times bigger as well. And the answer here is 90 using our known times table facts. 807 multiplied by 8. Well, again, look, just whack it into short multiplication. Why not? Let's make sure. And you'll notice they're choosing 8s and 7s because traditionally 8 times 7 is a tricky times table. Lots of children don't know. So it's testing you out. Do you know it? 8 times 7 is 56. And then 8 times nothing is nothing, but I've got my 5. So I whack up the 5 here in the 10s. 8 times 8, another tricky times table, is 64. So we get 6,456. Well done if you got that, because it shows you have a solid times table understanding. And if you weren't sure, you're going to get those questions wrong. So you need to learn your times tables. Long multiplication, something you learned first in year 5, is going to come up in these Key Stage 2 tests. So the first row here, I'm multiplying by 32. So my first row will be multiplying by 2, and my second row will be multiplying by 30. Let's do the 2 first. 2 times 4 is 8. 2 times 1 is 2. 2 times 6 is 12. Okay, cool. First step done. Then multiply by 30. I must put the placeholder in, and now I can just multiply by 3. 3 multiplied by 4 is 12. 3 multiplied by 1 is 3. Add the 1 is 4. And then 3 multiplied by 6 is 18. Then the last thing we do, once we have 30 lots of the number and 2 lots of the number, we're going to add them together. So I get 8 in the ones, 4 in the tens, 6 in the hundreds, 9 in the thousands, and 1 in the 10,000s. We get 19,648. And you might notice this is worth 2 marks. To get 2 marks, you get the right answer. Boom. To get 1 mark, you have to do all of the working out, but have made 1 arithmetic error. That does not count for getting your 0. If you forget this placeholder 0, you will get nothing. That's not an arithmetic error, that's an understanding error. So if, for example, you did 2 plus 4, and for some reason you put 7, then you'd get 1 mark because you've shown your working out. It says here, show your method. It's always best to do that. But the true answer is 19,648. Here again, a couple of methods. Can you notice that there is a hidden 20 in here? 20 divided by 4 is 5, and then put your 2 placeholders on at the end. And the answer is 500. Another way of looking at this is looking at divide by 4. You might know a shortcut here. Dividing by 4 is the same as divide by 2, and then divide by 2 again. So you could half the number twice. Half of 2,000 is 1,000. Half of 1,000 is 500. Multiple ways of getting to the same answer. Whatever you're confident with is the key here. What do you do that will get you the right answer? Question 16. We have 3 multiplied by 8.9. Nearly went off the screen. Again, just write it down. Imagine this was 89 multiplied by 3. You'd know exactly what to do here. You just write it like this. Just put a decimal in. It's 8.9, so the decimal is going to come down into the answer as well. Let's do the same method. 9 times 3 is 27. 3 times 8, that's going to give me 24, plus the 2 is 26. So I have 26.7. If you forget that decimal, you'll get it wrong. No matter how much good work you've done, you must remember that decimal. It really changes the answer here. Here we have a decimal to start with, 326.8 divided by 10. The key here is that when we're dividing by 10, 100 or 1,000, we are moving digits down the place value column. In this case, we're going to move down 1 place because 10 has 1 placeholder. So all of these digits are going to move. The decimal is going to stay where it is. The 8 shifts down 1. The 6 shifts across the decimal, and the 3 and the 2 budge up. So the answer here would be 32.68. That 6 has made the leap over because we moved one place down. Question 18, 1/3 take away 1/9. If ever we have to add and subtract fractions with different denominators, our first job is to make the denominators the same. Luckily for us, the denominator 9 is not having to be changed here because I can change 3 into 9. So as long as I move this, I multiply 3 by 3, do the same to the top, and I get 3/9. These are equivalent. And now the denominator is the same, I can very easily subtract. 3 take away 1 is 2. Therefore, that's the answer. 2/9. Get the denominators the same. 896 divided by 7. This is short division. So we're going to take 896. We're going to divide it by 7. And let's check this method out to see if you got this question right. How many 7s are in 8? Well, there's 1 7 can fit in 8 with 1 left over. That 1 gets exchanged over. How many 7s can we fit into 19? 1 7 is 7. 2 7s are 14. But 3 7s are 21. And that's too many. So 2 7s are 14. And then how many do I have left over to 19? Well, that's going to be 5. And now, if I know my times tables, again, look, it's testing. 7 times 8 is 56. It's come up multiple times because it's the trickiest times table. 7 times 8 is exactly 56. So we have 128 as the answer there. Here is a classic question for Year 6 children that we learn about place value when subtracting, because it's all about making sure your digits are in exactly the right place. And the bigger the number, the harder it is to do that. So now 52,346, I would actually start in the ones. I do the 6, the 4, the 3, the 2, and then the 5. And that just ensures that my digits are in the right place. Because what it's really important to do in this question, line up your ones. There's no point lining up your millions because there are no millions in the second number. So let's do some subtraction here. I feel like there's going to be quite a lot of exchanging. 5 take away 6, can't do that. So 15 take away 6 is 9. You can do 5 take away 6, of course. It's a negative number, but we don't want them in this question. 2 take away 4, let's do some exchanging. We have 12 take away 4. 12 take away 4 is 8. Oh my gosh, 1 take away 3. We need to exchange. We're going to have 3 here now, and 11 take away 3 is 8. 3 take away 2, phew, I could do that one. It's a 1. And now I have 0 take away 5. And actually, I could double exchange across here, get that to be 10, and then take one from the 10, get that to be 10, and have 9 left over, blah, blah, blah. Or you could just look at this as 100 take away 5. That's another way of doing it. And the answer would be 95. So just to confirm, look, you could do this, do some exchanging, double exchanging over, and you get the same answer. So the answer to this question is 951,889. If we wanted to say that number out loud, we would say 951,889. So much exchanging. Testing, can you line your digits up? The ultimate version of a subtraction question, really, where there's so many chances to make a mistake. 4,104 divided by 9. Again, it's such a large number. Let's get this into the bus stop method. And it's testing your 9 times table this time. How many 9s in 4? Obviously, none. And that whole number 4 gets exchanged over. How many 9s are in 41? How close can we get? Well, 9 times 4 is 36. And there'd be 5 left over. How many 9s can we fit into 50? Well, 9 times 5 is 45 with 5 left over. And then thankfully at the end, there's no remainders because we say how many 9s are in 54. There are 6 9s in 54. So the answer is 456. Can you see how many of the questions require solid understanding of those times tables? They really are so important. Take a look here. We've got 3 fractions, all with different denominators, and we're adding them up. We need to put all the denominators into the same number. And 12 is going to be our go-to. We already have a 12 here, so we're going to keep that because 3 and 6 both go into 12. So keep 3 over 12. Let's look at the middle one, 2/3. Well, how do I make that out of 12? 3 times 4 is 12. So do the same to the top to maintain equivalence. We get 8/12. And the first fraction, 1 over 6. Well, there are 2 6s in 12. Do the same to the top. And we get 2/12. So the question here becomes 2/12 plus 8/12 plus 3/12, which is much easier now to do. 2 plus 8 is 10, plus 3 is 13, and the answer is 13/12, which is acceptable. Lots of you will look at that, and you will say, I want to change that into 1 whole and 1/12 left over. That is acceptable. It's in the mark scheme. But my advice to you, look, just leave it like this. You're going to get the mark for that. This opens the door to making mistakes. So, you can just keep it as an improper fraction. That is fine. 17 take away 3.6. Again, this is all about lining up your digits properly. 3.6, the decimal would go past here. And what I would do is I'd put a 0.0 just for clarity, because how can I do 0 take away 6? Well, hopefully you'll understand that in this question type we can't do that. So we're going to take 1 from the ones column and have 10 tenths. 10 take away 6 is 4, put the decimal in. 6 take away 3 is 3, and then this 1 drops down here. 13.4. Nice one. Well done if you got that. 2 3/5 plus 1 3/5. Here's what I'm going to do. I'm actually going to separate the integers with the fractions. So we have two mixed numbers here. I'm going to do 2 plus 1, which is just 3. So easy. Then I'm going to do the fractions over here. 3/5 plus 3/5. Cool. That's 6/5. And now here's the problem. You can't have a mixed number where you have an integer and an improper fraction. You cannot have this. That's nonsense. If you've put some integers in, you have to sort this out. So how many wholes are there in 6/5? Well, 6/5 is the same as 1 whole and 1/5. So really what we've got here is 3 plus 1 whole and 1/5, which gives us 4 wholes and 1/5 left over, just like that. Well done for getting that one. 5% of 860. To find a percentage of an amount, well, we can find 10% very easily because it's just 860 divided by 10, and that would give me 86. So to find 5%, what's the link between 10% and 5%? Well, it's half. Half of 10% is 5%. So to find 5% of this number, we're going to half 86. Luckily for us, there's two even digits. We can very easily half this as 43, put our answer, and move on. It's as simple as that. 5/8 divided by 3. Now, if we're dividing by an integer, which we often get when we get fractions, we can actually have 5/8, keep that the same. We can flip 3 to be 1 out of 3 and multiply them together like this. So 5 times 1 is 5 for the numerator. Denominator is 8 times 3. It becomes 5 out of 24. If you think about it, this makes sense because dividing by 3 means we're getting smaller, and 5/24 is 3 times smaller than 5/8. So well done if you remember that method. Question 27, 19% of 2,300. In this case, there's a multiple ways we can do this. I'm going to show you one method. We can work out 1%. And we can work out 1% by dividing by 100, which is great for this number because it has two placeholders at the end. So 1% is just going to be 23. Then I want 19 of those percentages. So what you're going to do is 23 multiplied by 19. And if you know your long multiplication, you can work this out. Do times by 9 here and times by 10 at the bottom and then add them up. 9 times 3 is 27. 9 times 2 is 18 plus the 2 is 20. Then we're going to multiply by 10, put your placeholder in, and this becomes 230, just like that. So what we do at the end, we add these up and we get 437. That is 19% of that number, using the method finding 1% and then multiplying it by how much percentage points we need. There are lots of ways to work out percent. We've got a whole bunch of videos on our YouTube all about that. Go and take a look. Question 28. This is going to be long division. How many 17s are in 888? Well, you want to be building up a box over here by repeatedly adding together 17. So we're going to get 51. We're going to add another 17 here. We're going to get 68. We're going to add another 17 here, and we're going to get 85. Okay, so I'm going to stop there because I don't need to go any further. How many 17s are in 8? None. So think how many 17s are in 88? Well, we can see here we get very close with 85, and that is 5 lots of 17. So I'm going to take away 5 lots of 17, which I've just worked out as 85. See what I'm left with. 88 take away 85 is going to give me a 3. I'm going to drop the 4 down to get 34 here. And now the question becomes, how many 17s are in 34? Well, with our box, we've worked it out. It's just 2. 2 goes in exactly. Take away the 34. There's nothing left. And that is the end of our question. The answer is 52. Again, on our channel, lots of videos. I can think of one specifically about long division. Go and watch it if you're unsure. Question 29. 2 1/6 plus 2/5. So the first thing you should be noticing about this is that the denominators are different. But we can't keep one the same because 6 isn't in the 5 times table and 5 isn't in the 6 times table. So we need to find a common denominator. And we can do that by multiplying these numbers together to get 30. So 1/6. To make 30ths, I multiply by 5. Do the same to the top, 5/30ths. plus I need 30ths again, and to make fifths into 30ths, I multiply by 6. Do the same to the top, I get 12 30ths. Put my integer in, so I've got my mixed number now, and I've rewritten the question in a way which is much easier to work out. Because they're both 30ths, we can just add 5 and 12, which gets us 17. So the answer is 2 wholes and 17 30ths. Question 30, long multiplication. We're going to multiply by 4 here, then we're going to multiply by 70 down below. We have to be really careful here, because we're only allowed to make one arithmetic error to get a mark. So we have to be super careful, and this is a real test of our times table knowledge. 4 multiplied by 9 is 36. My little 3 there. Just making sure I don't forget it. 4 multiplied by 1 is 4, plus the 3 is 7. So I have 76 there now. 4 times 4 is 16, with the 1 exchanged over. 4 times 6 is 24, plus the 1 is 25. So I have 25,676. Cool. Now I'm going to multiply by 70. Put my placeholder in so I can do my 7s. 7 9s is 63, with the 6 exchanged over. Keep that in my head. I'm actually going to put it down here so I don't forget it. 7 times 9 is 63. Cool. 7 times 1 is 7. Add the 3 is 13. Going to whack it down here so I don't forget it. Doesn't get in the way. 7 times 4 is 28, plus the 1 is 29. Going to put my 2 down here so I don't forget it. 7 times 6 is 42. All these tricky times tables. It's no wonder it chose 7. 7 6s are 42, plus the 2 is 44. So I've remembered all my exchanging, and now at the end, I need to add this up really carefully. This is a huge question. Loads of times tables and adding at the end. 6 in the ones. 7 plus 3 here. What's that going to get me? Well, 7 plus 3 is obviously just 10. I don't need to worry about any of this exchanging down here. Just my addition now. 6 plus 3 is 9, plus 1 is 10. 9 plus 5 plus 1. Well, 9 plus 1 is 10, plus 5 is 15. 4 plus 2 is 6, plus 1 is 7, and then the 4 drops down. My goodness me. 475,000 with a 6 at the end. 475,006. Oh my gosh. If you're going to put commas into your answers here, make sure they do not look like decimals, because if it looks like a decimal, it will be marked incorrectly, because that's a completely different number then. Question 31, BIDMAS, order of operations. Wow. Let's take a look at this then. So BIDMAS, we have to do the brackets first. So it doesn't matter that there's division here. We have to do this brackets first. So 5 squared is 25 plus 3. Okay, cool. Minus 12 divided by 4. That's the first step. So I've got to do what's inside the brackets, which was the squaring first. Then I do 25 add 3. So that's going to be 28. I have to do this addition before I do this division, because it literally is the order of the operation. So I have 28 take away 12 divided by 4. It might be very tempted to do 28 take away 12 first, but remember your order of operations. Division comes before subtraction. So now we do 28 take away 12 divided by 4 is 3, and I'm left with 25 as the answer. A fantastic BIDMAS question, really testing your knowledge of order of operations. 65% of 540. Again, what I would be doing here, I'd be working out 10% by dividing by 10, because it's a nice number to divide by 10, so I get 54. And I'd be working out 5%, because I can do half of 54. Half of 50 is 25, plus half of 4 is 2, that's 27. Once I've got my bricks, I call them, my 10% brick and my 5% brick, I can work out 65%. So I'm going to do 54 multiplied by 6 to get me 60%. 4 6s are 24, 6 5s are 30, plus the 2 is going to be 32. So 60% is 324, and then 5% is 27. So to work out 65%, I'm going to add these two together. 324 plus 27. I'm going to get 7 plus 4 is 11. 2 plus 2 plus 1 is 5. And the 3 drops down. We get 351 as our answer. If we're confident finding 10 and 5%, we can work out any percentages that are 10s or 5s in them. Just like this one here, 65%. Question 33. 3 1/3 multiplied by 12. Well, here again, I would be splitting up the integer and doing 3 times 12 as one part, and I would be doing 1/3 times 12 as the other part, and adding them together at the end. 3 times 12 is just straight up times tables. That's 36. And then 1/3 times 12, well, that's going to be the same as 1/3 of 12. So we can just divide it by 3 and we get the answer 4. If I combine these together, 36 plus 4, the answer is 40. Question 34, long division. Again, we'll be making a little box over here. I call it a box. It can be whatever you want it to be. One lot is 45, 2 lots are 90. And it's actually going to be counting up, I think, of angles here. Then it's going to be 135, it's going to be 180, and then it's going to have another 45 on there, it's 225, it's going to be 200, and add on 45 here, it's going to be 70. Let's see if we need any more than that. 45 into 8, obviously don't go. 45s into 81. Well, look, 2 45s is too many. It's too much. So it's just going to be 145. So if I take away that 145, I have 81, take away 45, do a bit of exchanging here. 11 take away 5 is 6. And then we've got 7 take away 4 is going to be 3. And drop down the 9, we have 369. How close can we get to 369? Oh, I'm going to have to do another 45 here just to make sure. So I add that on, I get 315. Oh, I don't know. I think I can put another one in. Add another 45 here. I get 360. Okay, look. That's as close as I'm getting here. So how many 45s is 360? 1, 2, 3, 4, 5, 6, 7, 8. My goodness me. So I'm going to put an 8 in here and take away that 360. 369, take away 360. There's going to be 9 left over. Drop down that 0 is 90. How many 45s in 90? It's right here. It's exactly 2. So I put my 2 at the top. I take away that 90. There's nothing left. We are done. There are 182 45s in 8,190. My goodness me. Question 35. 3 8s multiplied by 240. Something to note here, that this multiplication symbol is just the same as saying of. So we're just working out 3 8s of that number. So I can write it out here like this if it helps. 3 8s of 240, but it's just the same thing. Divide by the denominator. So 240. Let's divide it by 8 into 8 equal parts. Use your times tables facts. 8 into 24, go 3 times. So this is going to be 30. And then I don't want 1/8. 1/8 would be 30. I want 3 of them. So multiply this by 3 and we get 90 as the answer there. And then question 36, the last one on the paper. Guys, make sure you like this video, subscribe because we've got all of the test papers coming, and leave a comment down below what was the hardest question before I solve this one. 4 3/7. Oh my gosh, it nearly wanted to end itself. No, not yet. We've got one more question. 4 3/7, take away 1 1/6. Again, your denominators are different. So I'm going to find a common denominator by multiplying them together, which is going to be 7 times 6. What's that going to be? You need to know your times tables. It's 42. So 7 times 6 gives 42. Do the same to the top. Is 18 40-seconds is how we would say that, I think. And then this other one here is going to be out of 42 now. What did I do to 6 to get to 42? I multiplied it by 7. Do the same to the top. Is going to be 7 40-seconds. Put your integers in, 4 and 1. And now we can do this without exchanging past a whole number. We've done the hard work. So 18 40-seconds, take away 7 40-seconds. That's going to give me 11 40-seconds. And then 4 take away 1 is just 3. So the answer is 3 and 11 out of 42. My goodness me. Some tricky questions in there. How did you get on? Let us know down below. And I'll see you next time for another video.